Hello, we are Team 2813, the Gearheads. I'm Kyle.
And I'm Sierra.
And welcome to our 4th Java training video.
Yay.
On today's agenda we have arrays, enums, and generics.
So let's talk about arrays. So arrays are basically a fixed size indexed list of information. So that means that the size of the array cannot change, and also each element in that array has an index you can use to get access it. And it can also only store one type of information. So for example, if you want to have an array with strings, then you can only have strings in it and you cannot have integers in it. So there's two ways to initialize an array. So you can initialize it like this with the default value, which you do the type, your square brackets, the name of your array, and then equals to new, the type again, and then in the square brackets you put how many elements are in that array. And you can also initialize it with the values itself. So you do the type, angular brackets, square brackets, the name of the array, equal, new, type again, your square brackets, then you use these curly brackets and then put all your information in there, like your values. So to access an element in an array, you use square brackets. So like here, for this array, for example, if you want to access the value at the index 0, which is 16 here, you're going to do the name of the array, your square brackets, and then the index number, and then and you can use that to change it as well. But if you only did that and you printed it out, it would give you 16, for example. You can also do it for other ones, and you can also change the value of them like this. If you change this to equal to 2, then this will become 2 instead. And then if you did this, then you would be subtracting 1 from this, which would become 14. You can also get index out of bounds exception, which means that the index doesn't exist, and Java will give you that exception. So for example, if we have this array called teams, and it has aerobotics and gearheads, and I try to get teams, and then I try to get the second index, and I change it to high tide, that's not going to work because you have your 0 here and your 1 here, and there is no index 2, which means it will throw the exception. You can also get the length of the array by just using .length. Enums. Okay, so enums are, or they're short for enumerations, but basically they allow you to have a type with a fixed set of possible values. So kind of just like a list of constants, if you want to think of it as that. And since each constant is only defined once, that means you can also use the equal for enums. And another thing is they're actually also classes, which means that you can actually put arbitrary information into the enums, and you can even create a constructor. So for example, you can create this kind of constructor, and enum constructors cannot be public, so they're just private by default. So why do we use enums? So if you take a look at these two, this is the one where you're using an enum, and this makes it a lot clearer because you're telling it, oh, okay, you're going to give me this kind of information, and this makes it a lot more general, but this makes it more specific. Another thing is you can also make more scalable code with enums. For example, for this one, if you use a boolean called is_Fahrenheit, that means that it's only going to be in the unit Fahrenheit for temperature. But if you use this enum value instead, then you can actually use different units like kelvins or Celsius and so on. There's also you can also use switch statements for enums. So switch statements basically are kind of like a fancy kind of if statement where you can check for equality. So for example, if I'm checking a unit, for example, in the case Fahrenheit, so if unit is equal to Fahrenheit, then you can check, then you're going to say, the amount will equal to 32. Or if it is equal to Celsius instead, the amount equal to 0. And how switch statements work is it keeps going until you see a break. So if it breaks, then it stops, but then if you don't have a break in there, it's going to keep going to the next case. And you can also put a default, which means that in the end, it'll obviously run into this. So if it's neither of these, then it'll give you an exception, or it'll give you an error. There's also methods that you can use with enum. So for example, the name method returns the exact enum constant name, and then toString can return also the name of the constant, but not it can't always be guaranteed to be exact. You can also use .value. You can also use the values method to give you every enum constant in the enum class. Okay, so now you guys are going to practice this. So this is your project. You're going to create a class to represent a person, and then in that class you're going to store the person's name, if they're a teacher or a student, and you can also, and then you're going to create a method to take an array of this class and index look at it, and also in that method print out a different message depending on the type of person. So pause now if you want to take some time to work this out, and then we'll give you the solution next.
Okay, so for this solution for this programming project, there are actually multiple ways to do this. Here we implemented it with a position to represent what kind of person it is. For example, we have student and teacher, which you can see here defined in enum. You can also do this with inheritance, and there's probably some other ways to do it. For this method, you need to have the name because you need to get the name, and you also need to pass the type of position. If you're using inheritance, then you just have a different class for each, for like a student and for a teacher. And then here in the print name, you just get the format string, and you have the %s to represent the student's name, and then everything afterwards. And then we just do a system.out.printf to actually convert that into what actually wants to be printed with the name. So that if it's a student, then it'll print like it's an amazing student. In general, when you're coding stuff like this, you usually want to use inheritance and not this, because this can usually make it a lot more complicated. Okay, next up we've got generics. So, generics allows you to write code that doesn't really care what type you pass it. All that code cares about is that the type is the same. For example, you can imagine a box. You want the box to hold some kind of value. You don't care what value it is, you just care that it's consistent, and you can actually specify what type it is. So, generic methods. So in this case, we have a generic argument, which is this left bracket, this right bracket, and then this t. This t right here is a generic argument. And that can be any class type. So you can't use this with primitive types. So, and then this is basically replaced here for A and B, which means that whatever t is, which in this case is string, is the same type for both A and B. So for example, we can say, okay, we call generic methods, and then we put the type of string, do something with A and B. Or usually Java can just actually infer the generic arguments, and you can just omit that and just put in arguments. And Java will complain if it can't actually find out what the generic arguments are. So, you can also have generic classes. So, for generic classes, you put the generic arguments next to the class name. For example, here we have a box of some generic argument t. And then it takes in 2 of whatever t is and stores them, and you can get either of them with these 2 methods. So, in order to actually make an instance, you would use new, the name of the class, and then you'd have in the square bracket, the angle brackets, the class, and then the things. Just like generic methods, the type it can assume the type, but you do need to put the angle brackets, whether or not you actually specify what it is. The exact reason for why this is, we're not going to get into, but if you don't, then Java will complain. It can be a bit more useful to have some generic type that fits some properties. So for example, you can say extends, and if you say extends, that means, oh, t is some type that is a subclass of this type. So for example, t would be any type that implements comparable of t. And even with interfaces, you still use extends. So in this case, list is a list of generic arguments, of some argument, that can be compared to itself. Another way to look at this is, in order to actually sort something, you need to compare them. And we're just saying we can compare the elements in this list to each other to actually be able to sort it. You can also have bounded wildcards. In bounded wildcards, you say, I want some type, but you don't actually care what type it is. So in this case, t is some type that implements comparable of some type that is a superclass of t. Java doesn't actually keep track of what that type is. It just cares that it is some superclass of t, and you won't have access to it. If you want to have access to it, then you can't use bounded wildcards. And then there's also this mnemonic PECS, or Producer Extends Consumer Super. So bounded wildcards should be preferred because it allows you to put more things. For example, if you have like a list of integers and integers are comparable to numbers, then it should still make sense since it can be compared to itself because an integer is a number. But with a division t extends comparable t, since integer doesn't implement comparable of integer, it wouldn't work. When you have some type that produces values, then you should put extends. When you are like this t, we have a list of t, and we're basically, that list is producing t, so we put extends. And then comparable, it consumes some t and says, hey, is it greater or lower? And since it consumes a value, we put super. If you have some type that both consumes and produces the value, then you can't use bounded wildcards. It needs to be exactly that type. Since generics only works with non-primitive types, in order to use generics with integers, floating point numbers, and booleans, you need to use wrapper classes. So here are some examples of wrapper classes. They all have uppercase letters and are all actually classes. And they allow you to perform generics with primitive types. In order to actually make this as easy as possible, Java actually has boxing and unboxing. So basically, for example, this method takes in an integer, but we can just pass in 10, which is actually an int literal. You're not actually creating an instance of integer. And Java will be like, oh, you want an integer. I'm going to automatically pass in that value, and it's going to convert it into an integer automatically, so you don't have to do it yourself. This is good because you get to write less code, but also it can be a bit more confusing because in the case of, oh, you have a method that takes both an int and an integer, it isn't clear which overload will be called. And in fact, here VS Code is giving us a hint and saying, oh, actually, this is the one that's going to get called. So, yeah. In this case, the int version is the one that gets called. You should always avoid arrays of generic types. If you need a list of generic types, you should use the type list, which we'll talk more about later. There are a handful of situations where it's okay, but you need to be very careful not to break generics by doing so. So here's an example of generic arrays being bad. So for example, we create an array of lists of strings, which has one item in it. We then turn it into an array of objects. This is actually completely okay with Java. Then we set this object list, the only element in it, to an integer list. And then we print out the only element in the list, which is this integer list, and we get the first item in it. So, due to how generics works, this will actually have an invisible cast string, and this will actually fail at runtime. So, because of how arrays work and how generics work, they don't really work together, and you can very easily write code that fails when it. So for our final programming project of the video, make an interface that defines a method for adding values. This interface must be generic and have a generic return type and a generic type that can be added to. Write a class that implements the interface and use the interface at least once in the main method. If you need a hint, or pause the video if you want to work on it. In a couple seconds, we'll reveal a hint. So as a hint, you can actually comma separate generic arguments. Feel free to pause the video if you want to actually solve the program project.